The paper of the day is the BW tree, a B tree for new hardware platforms. It's a 2013 paper. The emergence of new hardware and platforms has led to reconsideration of how data management systems are designed. However, certain basic functions such as key indexed access to records remain essential. Author's new form of B tree, called the BW tree, achieves its very high performance via a latch-free approach that effectively exploits the processor caches of modern multi-core chips. The storage manager uses a unique form of log structuring that blurs the distinction between a page and a record store and works well with flash storage. This paper describes the architecture and algorithms for the BW tree, focusing on the main memory aspects. The paper includes results of our experiments that demonstrate that this fresh approach produces outstanding performance. Now let's look at the performance evaluation. Paper provides experimental evaluation of the BW tree when compared to a traditional B tree architecture, that is Berkeley DB run in B tree mode, as well as latch-free skip lists. The experiments use a mix of real-world and synthetic workloads running on real system implementations. Since this paper focuses on in-memory aspects of BW tree, their experiments explicitly focus on in-memory system performance. Now coming back to contributions. Authors have designed and implemented the BW tree such that it can exist as a freestanding atomic record store, be a data component in a Deuteronomy style system, or be embedded in a traditional database system. They have followed the classic architecture of access method layered on cache manager, layered on storage manager. But at every level, they have introduced innovation that stretch prior methods and tailored their system for the new hardware setting of multi-core processors and flash storage. Authors' innovation, example, elastic pages, delta updates, shared read-only state, latch-free operation, and log structured storage, eliminate thread blocking, improve processor cache effectiveness, and reduce I/O demands. These techniques should work well in other settings as well, including hashing and multi-attribute access methods. Let's give this paper a PS score. Overall, it's a bumpy read, so it gets 8 out of 10 on readability. With 12 pages long, it scores 9 out of 10 on readability. Reproducibility might be challenging, so it gets 7 out of 10. Industry value is not proven, and not many commercial systems have adopted BW tree, so it gets 7 out of 10. Learning is decent, so it gets 8 out of 10, and that leaves us with the PS score of 8 out of 10.